Whenever bump mapping is being involved in a render tree, there's very specific computation and data being passed around between shaders in order to compute the bump mapping. One of this information is contained in an entity called the state, the shader state. Whenever Mental Ray computes a scene, every shader that gets evaluated will get a state, and basically a state contains all the detailed information about the ray tracing state at the moment where the shader is being called. For example, the state would contain surface normal, intersection point, UV information, barycentric, camera information, rendering option, so on and so forth. Now this state information is being passed from one shader to another throughout the render tree evaluation. So for example, if we compute, if we render a given scene, a camera ray will be casted in the scene and hit a given object. This when this ray hit the object, a given triangle will get evaluated. Every triangle has what we call a material being attached to that triangle, and that material may have surface, shadow shaders, bump map shaders, so on and so forth. The first thing that that Mental Ray will do in this case, specifically in XSI, is to evaluate the material being connected to the triangle. The first thing that Mental Ray will do is cook up what we call a state that contains all the required information for all the shaders to be able to do their job. So that state is a very broad container of information. So before the actual material gets evaluates the surface port, it needs to evaluate the bump map port, because if there's illumination shader being connected at the surface, on the surface port for example, the surface normal needs to be computed prior for the surface port evaluation. The material bump map port is designed to perturb the surface normal and should be considered as a global bump map. So any shader that is connected to surface, any illumination shader being connected to surface or shadow, will see this new perturbed normal. Now, whenever Mental Ray evaluates the material, it will send the state to the shader being connected on the bump map port. So the state gets carried over to bump map and given to the bump map generator. The bump map generator, in order to compute the new surface normal or the new perturbed normal, has to evaluate the texture 3 times. One at the intersection point, one slightly offset in the U domain, and one slightly offset in the V domain. So it's not really offset in space, but really there's an offset being applied to the UV information being extracted by the bump map generator. So the bump map generator will look up the UV that's been assigned in the shader and use that as a basis to compute the actual bump gradient or surface perturbed surface. The first thing that the bump map will do is compute the UV information for the intersection point. So it will attach what we call a state texture coordinate. So there's a very specific placeholder where the texture coordinate needs to be put. And whenever this information is given to Mental Ray along with the actual image, Mental Ray will do what we call the lookup. So the state gets carried over to the actual image, and Mental Ray will look up using the coordinate being provided in the state. And that will give a color information. It's not really a pixel, it's more like a sample. So this color information will then get returned directly back to the bump generator, which bump generator will keep this information handy to compute the bump map later. Now it has to do the same thing again by offsetting the intersection point slightly in U this time. So it will put a new texture coordinate in the state and then evaluate the image again. That will give a different pixel color because the UV information being given is also different. So the pixel is returned back to the bump generator, and then bump generator will accumulate this information and keep it for the final bump map computation. Again, now it has to do what we call the evaluation of the texture, where the UV coordinate has to be offsetted in V. So it will put the information in the state texture coordinate and evaluate the image, which will return a different color again. The pixel gets returned back to the bump generator. Now the bump generator has all the three information to be able to compute the new surface normal, because as explained in the previous session, you really need to have 3 points in order to create a triangle between these 3 points. And once this triangle is being computed, the triangle has a normal, and that normal is being used as the new surface normal. So now if we go back, now the bump map has computed what we call a new surface normal, and that information is being put in the state and also being returned at the output to the material. Now once the bump map generator says, okay, I'm done, and it returns the new surface normal back to the material. Now the material has all the information to be able to start evaluating the surface port. It will take the state and send it to the mixer node. The mixer node is not doing any modification to the state. It's a what we call, it's a generic shader. It has no dependencies. It can be called anywhere and any context. For example, the mixer color will not use any information from the state. It will take two colors and just blend them together. So the state is being passed to the next, or let's say the child shader, which is Fong in this case, in order to compute the surface normal. So now mix to color, before being outputting the final color, says, well, in order to compute the final color, I do have to evaluate base color, color, and also weight. In this case, weight doesn't have any shaders being attached to it. Will simply evaluate a static and a fixed color. Now the surface, the actual state, will be passed to Fong, because the mixer to color has evaluated the base color, and this shader now gets the state that mix to color had, and will proceed to evaluate. So even before Fong could return again a color information, a final color for that intersection point, it has to do a series of computation or calculation. So the first one of the things it needs to do prior to compute the surface normal or the shading has to make a backup of the state. The reason why it makes a backup is whenever the Fong is basically done with the shading computation, it will restore the backup here in order to leave this perturbed surface normal unaltered, even though the shader might affect it. So I'll explain a little bit later why this is needed. Even before computing the actual final shading, the Fong shader is required to evaluate the bump port first in order to have a new surface normal. So it will take the state and send it to the actual bump generator, and the bump generator again will evaluate 3 times the textures in order to find the new surface, the new perturbed surface. And once this work of sending different UVs information and getting back different color sample will compute a new surface normal, which is right here. So the white normal is the original normal when Mental called this render tree. The red normal here is the normal being computed by here. The green normal is the normal being computed by bump generator. So you see that the actual bump is basically accumulates every time a bump mapping is being applied. So that's why you see every time it accumulates, you'll see the bump map of this shader and this shader in the image. But we're not done. We have many stages of bump to do. So let's continue. It will return back the state to Fong, and also will return the new surface normal back to bump right here. Now the surface normal was perturbed a second time, and at this current stage it cannot really evaluate the shading because it has to evaluate the diffuse, ambient, shiny, and specular ports in order to get a value to compute the final pixel for this intersection point. So the Phong shader will proceed to evaluate the diffuse port in this case, and will transfer the state directly to the image shader. Now the image shader has to do a little bit more work than bump generator because it has to return two types of information. The first, let's say for example the image node doesn't have the bump mapping enabled, then in this case it will evaluate the texture only one time to be able to return a single color back to diffuse color in order to alter the diffuse color on the Phong shader. But let's say for example the image node has bump mapping enabled, then obviously it needs to evaluate the texture 4 times. The first one is to extract the color at the interpolation point, intersection point, and it needs to evaluate also the texture 3 times for the bump mapping. So the texture is being evaluated a total of 4 times. Once all this value has been gathered, from the texture, a new normal will be put back into the state, which represent the cumulated result of a 3 bump map process that's been done in the render tree. Now the actual color of the intersection point will be returned at the output of this shader back to diffuse, and as it returns the color, it will also return the state. Now the state is currently having the blue normal right here being pointing to a given direction. Now Phong will actually proceed and do the shading. So it will evaluate the light, it will take the surface normal, it will say, okay, the actual light direction and normal direction are pointing away, for example, and that means it could be in the ambient part of the shading, or it can be totally in the specular. So it will return and compute a pixel color for the intersection considering this new surface normal. Once the actual shading is totally done and computed and the final pixel is available to be delivered to the mix2 color, it will restore the backup state directly in the state in order to put back the original normal that was provided when the Phong shader got first evaluated. So now it will take this state and this Phong color and return it to mix2 color. Now mix color stored this information and says, okay, I need more information. I need to have the color 1 value. Now we'll take the state and then send it to blend shader. Blend shader will do exactly the same thing as Phong shader, where bump mapping, the state will be backed up first, and then the bump port will get evaluated. Now the bump returns a new surface normal in the state and also return a value, which is also the new surface normal, back to blend shader. And it will also do the same thing with image node, where the surface normal gets perturbed even further. Now it will return this value back to blend, and then blend will compute the new color for the current surface normal and all the lights being involved. Once the actual computation, the shading computation is done, the backup will be restored, where it will put the normal back to what it was before the blend shader being called. Then once blend is totally done with all these all the work, it will return back the normal and the color to the mix2 color. Now mix color has the base color and also the color 1 value, and can actually take these two values and blend it together. and then once it blends it together, it will take the actual state and the actual resulting color and send it back to the material surface. And then the material will send it back to the frame buffer to be able to shade a subpixel or a pixel, for example. Voila. As you can see, there's a lot of steps or phase being done throughout the render tree just to compute a single subpixel or pixel. So if we play it back, you see that there's enormous, a lot of work being done throughout the process, and just in order to perturb the surface normal and get this the result that you see. Now, the reason why the Phong and Blinn do compute the bump map and restore the actual state backup one done is that we don't want the bump map being done here at this level to show up in the Blinn. We want to localize the bump mapping to Phong only, for example. So for example, if Phong and Blinn didn't make any sort of state backup at all, it means that Blinn would get the bump map for this shader, would get the bump map of this shader, this shader, this shader, this shader. So it would really shade incorrectly at this level. So that's really important that the Phong and every illumination shader that has a bump port does a backup in order to localize the effect. So this is what we call a global bump map. So it means that any shader being connected to the surface will reveal the bump map. Any shader actually that use the surface normal will actually reveal the bump map. So for example, any illumination shader, any simple illumination shader, incidence for example depends on the surface normal, will also reveal the bump map. And here, these shader here are considered to be local bump map, local to Phong. And same thing here, these two are local to Blinn. So I just hope that this clarifies how bump mapping is being done in a render tree, and I just hope you enjoyed this session.